This is number 27 on page 310, and this problem is a quadratic equation in standard form, and we're going to complete the square to solve it. I'm guaranteed by the fundamental theorem of algebra 2 solutions. So the first two things I have to do are move this value c over to the other side, the constant, and complete the square on these terms, but I also have to have a equal to 1, and so I have to divide every term by 3. It doesn't really matter which order I do that in, so now I've got a 1k squared, which I need to complete the square, plus 5/3 k, and then I'll move the 2/3 now by subtracting 2/3 from both sides, because I still have a 0 on the right. So plus blank equals negative 2/3 plus blank. So I'm leaving blanks where when I complete the square I have to add the same thing to both sides to keep the equation balanced. So now I'm going to take half of 5/3, which is 5/6, and I want this to factor to be k plus 5/6 quantity squared, this polynomial on the left side. So when it does, to complete the square here, I'll have 5/6 squared, which is 25/36. So I have to add that on both sides. So that now gives me the left side in factored form, written as a squared binomial, equals this value on the right side. So negative 2/3, if I rewrite that over 12, multiplying by, over 36, multiplying by 1 in the form of 12 over 12, that's a negative 24/36. And when I add that with positive 25/26, I just get 1/36. So this is the ideal position that you want to be in. Squared expression equals number. So now I can take the positive and negative square roots of both sides. This is the square root of 1 over the square root of 36, so it's just 1/6. And so I have k plus 5/6 equals positive or negative 1/6. And so subtracting 5/6 from both sides, I now have k is equal to negative 5/6 plus or minus 1/6. So there's two paths that are created, the plus path and the minus path. The plus path is negative 5/6 plus 1/6, and the minus path would be the negative 5/6 minus 1/6. So negative 5/6 plus 1/6 is negative 4/6, which is negative 2/3. And the minus path, this gets me to negative 6/6, which is negative 1. So the two solutions, I would leave the check to you, you could do them with a calculator, are negative 2/3 and negative 1. And that is it.